Welcome to my Year 9 students. We are going to talk about enlargements today. I'm going to walk through a couple of the questions that you have been tasked to do. First of all, we're going to start with 15D. And in 15D, we have a rectangle, which is, I think, 2 squares down and 3 squares across. This is called rectangle A. So here's our rectangle. Okay, and this is A, and we are being asked to enlarge it with a scale factor of 2. So what happens is you can see that this is a 2 by 3 rectangle. So if we're enlarging by a scale factor of 2, the side that is length 2 now becomes 4, and the side that is 3 now becomes 6. So the lengths and widths are twice as long. Okay, we'll call this A dash. Now, we have to find the area. So in the first example here, area is equal to 3 times 2, which is equal to 6 units squared. But in the second one, the area is now equal to 6 times 4, which is equal to 24. Now, this might make you a little bit confused, because the scale factor of enlargement was actually 2. But if you look at getting from 6 to 24, it's actually times by 4. So we're just going to briefly talk about why that is. So what does a scale factor of 2 actually mean? Well, it means that every side is multiplied by 2. And since when we're talking about area, we're talking about 2 dimensions, then both of those dimensions are going to be multiplied by the scale factor of enlargement. So in this case, it's going to be 2 squared, the times original area will give you new area. Okay, so that's the general idea. If the scale factor of enlargement is 2, then the scales of the area will be 2 squared. And we could change things a little bit, and let's say we had a slightly different example. Let's say that we had a little square like this. Very nice, very nice. So it's 1 by 1, so its area is obviously 1. Now let's say we enlarge this by 3. So instead of 1 by 1, it's now going to be 3 by 3. So we've times this by 3. And we've times this by 3. And now you can see that the area will be equal to 9 squares, 3 by 3. And so scale factor of enlargement is, in this case, 3. But the areas, we're going 3 squared times original area. And the reason we're doing that is because the scale factor of enlargement applies to lengths. So we times each length by the scale factor of enlargement, but in a 2D shape, you have 2 dimensions. So each of those dimensions must be multiplied by the scale factor of enlargement. So they're going to be both times by 3, which means that the area will be times 3, or 3 squared bigger. So that's a little bit of an introduction to how enlargements change, a scale factor of enlargement changes area. Now I'm going to move on to exercise 15E. And I'm just going to look at question 3 first. So in question 3, I have a shape ABC, and A is at 1, 1, B is at 4, 5, so I'm just plotting these now, and C is at 2, 4, so it looks like this. We've got a skinny sort of triangle like this, and then we also have P, Q, R. Now P is at 2, 0, which is here, and Q is at 8, 8, which is here, and R is at 4, 6, which is there. And then we just join them up nicely. And I think what we're told here is that PQR is an enlargement of ABC. And the way we find enlargements when we've got both drawn is we draw straight lines joining the corresponding points. So I hope you can see that this point well, that's not a good color for this. I hope you can see that this point here corresponds to this point here. So we join these up, and you can see that we'll have a line that goes like this. Now it'll be easier for you guys because you'll have a ruler, and it's a bit harder on a computer screen to show this, but I'm drawing a nice straight line through there, relatively straight line through there, okay, like so. And then obviously I can relate this one and this one together, so I'm going to draw a straight line that joins them up, and that looks to me to be meeting here. I'll do one more. I'm going to show that these two correspond to each other, so I'm going to join them up, and that looks to me also with my ruler to be meeting at that point there. So I would say the center of enlargement is at, now that is 0, 2, because it's 0 on the x-axis and 2 on the y-axis. Okay, so that's our center of enlargement. Now I'm just going to get rid of some of this excess nonsense. Okay, now the other thing that we have to find out is what is the scale factor of enlargement. Okay, in other words, what have we done to the lengths? So if we look at this length here, it's gone across 2 and up 1, whereas this length here, which corresponds to that, has gone across 4 and up 2. So everything is being doubled. So we're going to say scale factor of 2. Okay, I hope that makes sense for you. Now, sometimes we have to do it the other way, so I will just delete some of this, and we'll do number 4 as well. So for number 4, we have a triangle T, 2, 1. So I'll pop that in, 2, 1, which is here. 4, 1, which is here. And 4, 2, which is here. So nice wee right angle triangle. That's T, below T. Now, we are enlarging it, and this time we're told where our center is. Our center is at 0, 0, so that's our center. And we're doing it by a scale factor 2. So what I do with this is I start with one of the points, and you can see that I've gone across 2 and up 1. So if I've gone across 2 and up 1, if I'm doing a scale factor of 2, I've got to multiply everything by 2. So instead of being across 2 and up 1, I'm going to be across 4 and up 2. So that point is now going to be here, which is a bit unfortunate. Now, let's look at this point here. Okay, now you can see that originally, going from my point of origin, 0, which is our centre of enlargement, I've gone across 4 and up 1. So if I double that, I go across 8 and up 2, which brings me to here. So now you can see this is the base of my triangle. The only other point I've got to get is this one that's also become part of the new one. So let's look at that. Where does that now go when we enlarge it? Well, you can see that it's across 4 and up 2. Now, if we double that, it's going to be across 8 and up, what's double 2? 4. So it should be up here. So our new triangle should look like that. So the coordinates of the vertices that I have are 4, 2, and then 8, 2, and finally 8, 4. And that is that. I suggest that you try, if you've only just watched this video and you haven't tried any on your own, maybe try another one. Perhaps try something like number 5 or number 6. Alright team, hope that goes well for you.